So before 5000 BCE, people in Mesopotamia were making fine pottery from a clay that consisted largely of an aluminum compound, and almost 4000 years ago, Egyptians and Babylonians used aluminum compounds in various chemicals and medicines. Pliny the Elder refers to aluminum, now known as alum, a compound of aluminum widely employed in the ancient and medieval world to fit dyes in textiles. In the latter half of the 18th century, chemists such as Antoine Lavoisier recognized alumina as the potential source of a metal. Here we have Antoine Lavoisier, and here we have aluminum, element number 13. So crude aluminum was isolated in 1825 by Danish physicist Hans Christian Ørsted by reducing aluminum chloride with potassium amalgam. Here we have aluminum chloride and potassium amalgam, and he reduced aluminum in that way. And Hans Christian Ørsted was a Danish physicist and chemist who discovered that electric currents create magnetic fields, which was the first connection found between electricity and magnetism. Ørsted's law and the Ørsted unit are named after him according to Wikipedia. He was born August 14, 1777 in Denmark. He died March 9, 1851, also in Denmark. He discovered aluminum. Here we have aluminum chloride. Aluminum chloride, also known as aluminum trichloride, describes compounds with the formula AlCl3n. They consist of aluminum and chlorine atoms in a 1:3 ratio, and one form also contains 6 waters of hydration. Both are white solids, but samples are often contaminated with iron 3 chloride, giving a yellow color according to Wikipedia. Its formula is AlCl3. Its IUPAC ID is aluminum chloride. Its molar mass is 133.34 grams per mole. Its melting point is 378.3 degrees Fahrenheit or 192.4 degrees Celsius. Its density is 2.48 grams per centimeters cubed. It's soluble in water. Its pH level is around 2 to 3 according to libertex.org. So what is potassium amalgam? Potassium amalgam, KHG, is a gold-colored compound with a melting point of 178 degrees Celsius. KHG2, a silver-colored compound with a melting point of 278 degrees Celsius. British chemist Sir Humphrey Davey had prepared in 1809 an iron-aluminum alloy by electrolyzing fused aluminum oxide, Al2O3, and had already named the element aluminum. The word later was modified to aluminum in England and some other European countries. German chemist Friedrich Waller, using potassium metal as the reducing agent, produced aluminum powder in 1827 and small globules of the metal in 1845, from which he was able to determine some of its properties. So here we have Friedrich Waller, and here we have Sir Humphrey Davy. So Sir Humphrey Davy was an English chemist and inventor from Cornwall who invented the Davy lamp and a very early form of arc lamp. According to Wikipedia, he was born December 17, 1778 in Penzance, United Kingdom. He died May 29, 1829 in Geneva, Switzerland. His nationality was British. So here we have Friedrich Waller. Friedrich Waller was a German chemist known for his work in inorganic chemistry, being the first to isolate the chemical elements beryllium and yttrium in pure metal form. He was the first to prepare several inorganic compounds, including silane and silicon nitride. According to Wikipedia, he was born July 31, 1800 in Frankfurt, Germany. He died September 23, 1888 in Germany. So Sir Humphrey Davy isolated aluminum by electrolyzing fused alumina or aluminum oxide, Al2O3. So the new metal was introduced to the public in 1855 at the Paris Exposition at the time that it became available in small amounts at great expense by the sodium reduction of molten aluminum chloride through the Deville process. When electric power became relatively plentiful and cheap, almost simultaneously Charles Martin Hall in the United States and Paul-Louis Toussaint Héroult in France discovered in 1886 the modern method of commercially producing aluminum. Electrolysis of purified alumina, Al2O3, dissolved in molten cryolite, which consists of the elements sodium, aluminum, and fluorine. 3 atoms of sodium, 1 atom of aluminum, and 6 atoms of fluorine. So here we have the elements sodium, aluminum, and fluorine. Here we have Charles Martin Hall. Charles Martin Hall was an American inventor, businessman, and chemist. He is best known for his invention in 1886 of an inexpensive method for producing aluminum, which became the first metal to attain widespread use since the prehistoric discovery of iron. He was one of the founders of Aloka, according to Wikipedia. He was born December 6, 1863 in Thompson Township, Ohio. He died December 27 in 1914 in Daytona Beach, Florida. He was awarded the Perkin Medal in 1911, and his siblings were Julia Bernard Hall. Here we have electron power. He used electron power reduction with sodium amalgam, and here is the Paris Exposition in 1855. This guy invented the machine that helps separate aluminum. Paul Héroult, French inventor. So Paul Héroult was a French scientist. He was the inventor of aluminum electrolysis and developed the first successful commercial electric arc furnace. He lived in Thury, Harcourt, Normandy, according to Wikipedia. He was born April 10, 1863 in Le Homme, France. He died May 9, 1914 in Antibes, France. His education was in mines in Paris Tech. Continuing on. During the 1960s, aluminum moved in first place ahead of copper in world production of non-ferrous metals. So here we have aluminum. And here we have the process. In a modern smelter, alumina is dissolved in reduction pots, deep rectangular steel shells lined with carbon that are filled with a molten electrolyte consisting mostly of a compound of sodium, aluminum, and fluorine called cryolite, according to Britannica.com. Another fun fact about aluminum is that if aluminum forms a perfect glass crystal, it forms a clear metal that we call sapphire. And sapphire crystal is included in many products, many devices, and it's even found in nature. Sapphire is just crystallized aluminum with oxygen. So here we have the rows. In actual practice, long rows of reduction pots called pot lines are electrically connected in series. Normal voltages for pots range from 30,000 to 300,000 amperes. From 50 to 250 pots may form a single pot line with a total line voltage of more than 1,000 volts. Power is one of the most costly ingredients of aluminum. Since 1900, aluminum producers have searched for sources of cheap hydroelectric power, but have also had to construct many facilities that use energy from fossil fuels, which include carbon and hydrogen in refined fractions. In 1940, that figure was 19 kilowatt hours. By 1990s, the amount of electrical energy consumed for each kilogram of aluminum produced has declined to about 13 kilowatt hours for the most efficient cells. So that was aluminum history explained in 8 minutes or less. Thank you everyone for watching. Let's continue with how aluminum was made back then and some more fast facts about aluminum, the smelting process specifically, and how and where it's extracted on Earth. Now that we have the key details of its history, let's continue with those other key details. If you like this video, make sure to like, comment, subscribe. I'm splitting up the usually longer element videos into shorter videos so they're easier to digest and watch. So if you like this video, make sure to like, comment, subscribe. If you didn't like this video, leave a comment below to let me know what can be fixed. Other than that, thank you everyone for watching. Let's continue with the next video. For now, have a great one.